Our today's topic is to solve linear equations. We can solve the linear equations by multi ways, but today I want to focus on matrix inversion method. You can find the Cramer's rule in my next video. Okay, let's discuss matrix inversion method. For the matrix inversion method, for example, in here, if you see, I have the two linear equations. Why it's linear equation? Because the power of variable is 1. If you see in here, I have 2x minus 2y. If you see the power of x is 1, power of y is 1. So whenever you have the exponent, I mean the power of exponent is 1, so that equation is known as a linear equation. Similarly, if you see the next equation is also linear equation. Okay, for the matrix inversion method, first of all, let's transform this linear equation in a form of the matrix. Okay, for this purpose, first of all, let's choose the matrices. With the help of matrix, we can easily adjust our equations. This is equation and okay, students, if you see in here, I have the two equations. If I have the two equations, then the matrix, the row of the matrix will be 2 by 2. That's why I choose the order of the matrix 2 by 2. Okay, if you see in here, in the first equation, I have two. The constant of the x, the coefficient of the x is 2. So just write 2 in here. And then if you see, I have the minus 2y. So just choose minus 2 in here. Just transform the linear equation in the form of the matrices. Okay, in the next equation, if you say I have the 3x, so just write 3 in here. And then if you say I have the plus 2y, just write 2 in here. Okay, then in here, I have to choose the another matrix. And for this matrix, I want to write the order, the coefficients. In here, in this matrix, just write the coefficients. Okay, if you see in here, I have the just two coefficients. Sorry, not the coefficients, variables, x and y. So just write x in here and y in there. Then put the sign of the equality and then choose the another matrix for the constants. If you see here, I have the constants plus 4 and plus 6. Okay, so just choose the matrix notations 4 and then 6. If you see in here, I just transform the linear equation in the form of the matrices. So this is the first step. Whenever you're going to solve the linear equation by the matrix inversion method, so first of all, just transform it from the linear equation in the form of the matrix. Okay, the next step is, for example, say this matrix is equal to the A for you, and this matrix, which is xy, it's equal to, for example, capital X, and this matrix, for example, say it's equal to the B. If you see in here, I have A multiply with X is equal to B. If I put, these variables according to this equation systematically, then I see AX is equal to the B. This is matrix A and this is X, which is equal to the B. It means I'm going to multiply A with X. So AX is equal to B. Okay, my demand is to find this X, this capital X. Okay, for this, it means I have to shift this A from left side to the right side. Capital X is equal to the B multiply with A inverse. In here, when I shift this A from left side to the right side, so it will be in terms of division, but in the matrix form, it's better to write it in the numerator. Just keep it in the numerator, not in the denominator. Okay, so this is the now format to solve the way this X. Okay, if you see in here, now I have the A inverse. It means now I have to find this A inverse first. Okay, if you remember in the previous video, I told you how can we find the inverse of the any matrix. Okay, for the inverse, first of all, let's write the formula in here. For more detail, just check the previous videos and you can find the link in the description. Okay, A inverse is equal to the, this is basically equal to the adjoint of A, adjoint of matrix A divided by determinant of A. And I also, determinant of just A, just a second. And for the more detail about the determinants and about the adjoints, just go to the previous videos. Okay, this is the formula. How can I find the A inverse? I mean, how can I find the inverse of any matrix? Okay, in here, first of all, I have to take the determinants. Okay, for the determinants, just write the matrix in here. Okay, if you see, this is my matrix A, which is equal to 2, minus 2, 3, and 2. So let's take the determinants in here. This is the way. Okay, whenever you are going to take the determinants, so the sign of the matrix should be transformed into the simple straight line. Okay, then write the digits in here: 2, minus 2, 3, and sorry, 3 and 2. Okay, so for the determinants, simply multiply diagonals with each other and then subtract it. I mean, 3 multiply with 2 multiply with 2, it will be 4, minus 2 multiply with plus 3, so it will be minus 6. It's a formula. Okay, whenever you're going to multiply the diagonals, so just put the negative sign in here. One more step, 4 minus minus plus, it will be plus 6, which is equal to the 10. And if you see in here, 10 is not equal to the 0. When it's not equal to the 0, it means it's non-singular matrix. When it's non-singular matrix, then we can solve it, we can proceed. Okay, so now I have the determinants. Let's take the adjoint. For the adjoint, simply for the adjoint of A, just interchange the diagonals and change the sign of the remaining entries. Let me show to you what I want to say. For example, this is the matrix. This is our matrix 2. This is matrix 2, minus 2, 3, and 2. Okay. For the adjoint, simply change this entries. If you see in here, I have to take this 2 from here to there, but in here right now I have the same constant, so it means there is no changes. And then just change the sign of this constant from here. For example, if you see in here I have minus 2, so just put plus 2 in here. In here, if you see, I have plus 3, so it will be minus 3 in here, if you see. Okay, so this is the adjoint of this matrix. Whenever you're going to take the adjoint, simply interchange this diagonal with each other, and then just change the sign of this diagonal. Okay, now if you see here, I have the adjoint of A, I mean adjoint of this matrix, as well as I have the determinants of the A. So let's put the values in here. Okay, A inverse is equal to the, it will be like this. A inverse is equal to the adjoint. Okay, if you see in here, adjoint of A, just put the values in here. Adjoint of A, which is equal to the 2 plus 2 minus 3, 2, and I have to divide by determinants of this matrix. So let's write the determinants first in here. Okay, for the determinants, if you see the determinants is equal to the 10, it means I have to write 1 divided by 10. It's in the denominator form. Okay, then I have to choose the bracket for the adjoint of A. I mean, if I want to write the adjoint of A. Just a second. Okay. This is the 2 by 2 matrix. Okay. When I write the adjoint, it will be 2 plus 2, no need to write it, plus minus 3 and plus 2. Okay, this is the A inverse. Okay, if you see in the equation first, in here, I have to multiply A inverse with the matrix B. Okay, let's do it together. Capital X is equal to the A inverse, which is exactly equal to the 1 by 2, 1 by 10, sorry, it's not 1 by 2. 1 by 10, this is 1, this is 1, and divided by 10. Okay, then I have to write the matrix, which is equal to, just a second, I want to short this video as much as I can because the lengthy videos most of the time irritate the people. Okay. Let me choose it once again. In here, 1 divided by 10. Then I have to take matrix bracket in here first. Okay. It's like this. Okay. New equation. Sorry for the inconvenience. It's 2 by 2. Okay. 2 plus 2 minus 3 and then 2. Okay, now I have to write the matrix B also in here. And what is the matrix B? Matrix B is basically my constant term and it is 4 and 6. Okay, let's write it in here. When you write it, then you have to multiply your terms in here. It's 4 and in here I have 6. Okay, now my equation is almost ready for the further simplification. In here, if you see, I have to multiply this matrix with this one. And the rule of the multiplication is similar as I described in my previous videos. Simply multiply this row with this column. Let's do it together. Capital X is equal to 1 by 10. Once again, I have to write it. 1 by 10. This is 1 and this is 10. Okay, and then in here I have to multiply it. So let's choose the equations, symbols for the better understanding. Okay, when you multiply 2 with 4, so you will have 8. Then put the plus sign. 2 multiplied with 6, it will be 12. Okay, in here I need just 1 by 1 matrix. This is the 1 by 1 matrix. Okay. When you multiply 2 with 4, so it will be 8. And then put plus sign. 2 multiply 6, it will be 12. If you see, this is the first row, this is the first column. So I just multiply first row with first column. Similarly, now let's multiply second column with the first row. Minus 3, when you multiply minus 3 with plus, so you will have minus 12 plus 2 multiply with 6, it will be plus 12. Okay, so let's do one more step for further simplification. And in here, when I simplify it, first of all, let me write 1 by 10 in here. Okay, capital X is equal to 1 by 10. This is 1 and this is 10. I will increase the size. Don't worry about the size. Just 1 or 2 steps are left for the final answer. In here, the matrix is this one. Okay. Plus 12 plus 8, it will be 20. And minus 12 plus 12, it will be 0. Okay, now just take this 10 from outside of the bracket inside. And when you divide 20 by 10, so you will have just 2. I mean, in the first row, you will have just 2. If you see this, the 10 is in the denominator. So just divide this 10 by 2 is by 20. So you will have just 2. It's better to solve this determinant at the end, because in here, if I divide this 10 inside of this matrix, so I will have some equations in the term of the fraction or in the decimal. So it will be difficult for me to control it. But it's better to solve this determinant, which is in the outside of the matrix at the end. Okay, when I divide it in here, if you see, I will have just 2. And when you divide 0 by 10, so you will have 0. Okay, in here, if you see, this capital X is basically equal to the X and Y. I mean matrix X and Y. It means X is equal to the, this capital X is equal to the matrix X and Y. It's equal to the, okay, just a second. Okay, this capital X is equal to the X and it's equal to Y. And furthermore, if you see this x is equal to the 2 and 0. Okay. I mean in the matrix, if you see, I have just 2 and 0. Let me write it in here first and then tell to you. This is 2 and in here you have just 0. Okay, it means from here you can say that x is equal to the 2 and y is equal to the 0. So this is value of x and y. If you want to check either your answer is correct or not, simply put these values, I mean the value of x and y in your original equation, then you will come to know either your solution is correct or not. Whenever you have the value of any variable, for the checking, just put these values in the original equation, either in equation 1 or 2. If left hand side is equal to the right hand side, it means your solution is absolutely right. So this is the matrix inversion method. I mean, if you have the any linear equation, so you can solve the value of x and y with the help of this method too. For the Cramer rule, please check my next video.